a look at this snow cone. We want to find the surface area. So we have this cone here, but if you think about it, we don't have this circle part. We don't have this base. We just have this outside part. Okay? So if we think about just that outside part, that's going to be the pi times the radius times the slant there. That will give us this part. But then we have this part up here. This part up here is basically half of a sphere. That dome part is half of a sphere. So a sphere has a surface area of 4 pi r squared. But we only want half of it. So we're going to add those two together to get our total surface area. Well, that 6 inches is actually our diameter. So our diameter is 6 inches. Our radius is half of that, so our radius is 3 inches. And then our slant height is 5 inches. So we have pi times 3 times 5 plus 1/2 of 4 times pi times 3 squared. So this would give me 15 pi plus half of 4 is 2 pi times 9. So that would be 15 pi plus 18 pi, which would be 33 pi inches squared, or approximately 103.62 inches squared. So you really have to think, I don't want the full cone like we did previously, because I don't have that base. So I don't want to add in the circle here. I just want this part of it. And then I want the top part, so that's like a sphere, but I only want half of it. Okay? Now, let's look at this pyramid. So I have this base. It's 4 centimeters by 4 centimeters, so it's going to be a square. That's not that big of a deal. 4 times 4, that's going to be 16. So surface area, I know, will be 4 times 4. Or let me just start out by saying side times side. Or side squared. But then I need to know about each of these lateral heights. This side right here is not the lateral height. This is actually the altitude, or from the center to the center. And if you recall, the formula for a pyramid was the base plus the number of sides times 1/2 of the side times L times the slant height. Okay? Because that was the formula for the triangle. Well, I don't have the slant height. I have this altitude. But I can find the slant height if I draw a triangle, because that would give me that slant height. This would give me that right triangle with one side being 6 and the other side being half of 4, because I would have this whole thing being 2. I'm sorry, this whole thing being 4. Half of that would be 2. 6 squared plus 2 squared would give me my L squared, slant height. So that would be 36 plus 4 would be my slant height. So that would be 40 is equal to L squared. So the L would be the square root of 40. And the square root of 40 can be broken down. If I think about 40, that's 4 times 10. 4 is 2 times 2, and this is 2 times 5. I have a pair of 2's. They can come out. This I don't have a pair of, so those go back in, so add and make a 10. So square root of 40 is 2 square root of 10. So my surface area will be 4 squared plus I have 4 sides, 1, 2, 3, 4, times 1/2 times the length of my side, which is 4, times my slant height of 2 square root of 10. So 4 squared is 16. Half of 4 is 2. 2 times 4 is 8. I multiply by the number outside. 8 times 2 is 16. 16 square root of 10. I cannot combine these. Please do not say that that is 32 square root of 10. In order to combine these, those would both have to have square root of 10. I cannot combine these. My answer is 16 plus 16 square root of 10 centimeters squared. I know that looks horrible. That would be our exact solution. Our approximate solution would be 1,256 centimeters squared. Nope, that would not be right. I'm looking at the wrong one. I do not have the approximation for that one for some reason. Let's see here. That would be 16 plus 16 times the square root of 10. That would be approximately 66.6 centimeters squared. Now let's look at the sphere with a diameter of 20. So we know diameter is 20. That means the radius is going to be half of that, which is 10. Surface area is 4 pi r squared. So we have 4 pi times 10 squared. 10 squared is 100. 100 times 4 is 400 times pi. So we have 400 pi inches squared, which is approximately 1,256 inches squared. Again, a lot of this is just being able to plug it into the formulas.